Hi everyone. Today we're going to be talking about multiple regression, model creation, and model conditions. And we're going to cover several topics, including a review of the regression equation, the linear regression, the regression models are built, and interpreting the predictors. And then we'll talk about model selection strategy. What are the model conditions, the assumptions about the models that we need to keep track of to make sure that our models actually makes sense and it's valid. And then we'll talk about how these apply to logistic regression more specifically. So let's recall what the regression equation is. And we're talking about the regression equation, we're talking about linear regression, right? So linear regression, that's a linear model. And we build regression models from the equation of a line, and we have a value that we want to predict on the left side, and then we're going to have values on the right side of the equation, which will get coefficients, which are kind of like weights to these variables that will help us understand how much any one particular variable contributes to another. And we can have, in linear regression, we can have one or multiple, what we call either predictor, explanatory, or independent variables, and how they are associated with one particular outcome variable, also called dependent variable or response variable. Now let's remember, this is not a causation. The model just associates numbers. Okay, so you can't just say because you put it in a model and then it sums up and it's a cause. That's not how we get cause. Here we just have association of numbers, and when we put these multiple variables into one equation, actually what we do is we're able to control for all the other ones. So when we have an equation like this, what this means is that we can find the impact of one particular variable on the outcome variable controlled for the other ones. Here's some notes here. We've already gone over this. You can review some of these videos on multiple regression. And the basic idea is that when we look at a 2 dimensions, so suppose we're looking at just 2 dimensions, it works with multiple, but it's easy to visualize too. So we have a predictor variable such as amount spent on advertising in thousands of dollars. Each dot is a location, and each location spends a different kind of amount. And then there's also the revenue of that location. So here what this data seems to show is that there's many locations. Each location has both revenue and amount spent on advertising. And we can see that in the aggregate, when we collect all of this data, we see a linear relationship. It seems to be going, it seems that the more a store spends on advertising, the more revenue it gets. Now notice that some stores over here, they seem to spend a lot on advertising. Right, all of these points I'm circling, but they actually have very low revenue compared to everybody else. All of these on the bottom here. However, on average, in general, the pattern is going up. So I got to remember that as well. In some of the examples, we're working with bankruptcy data and interest data. And remember that we can build a regression equation like this with just text. And I may look for you to do this in one of your projects. So the idea is that you can identify a particular outcome variable of interest. So here can be like an interest rate in this example. And then we simply list all the variables that we think are associated with a higher or lesser interest rate. Note that this is numeric and continuous. And continuous means that you can have a decimal point. It's not just count or integer data. And for regular linear regression, this dependent variable needs to be continuous. But the other variables can be different types. And here we have many variables that we assume may explain in the interest rate. So these are credit utilization, the bankruptcy, the number of credit checks a person has had, the debt to income. All of these are attributes of a person. So the unit here is a person, and this is the interest rate that the person may get. So what happens is, to build a regression model, we need to estimate the coefficient. And generally we estimate the coefficient by the sum of the squared residuals. It's also called OLS, ordinary least square. So the idea is that we have data, we have a data set. I don't know if I have an image here, but we have a data set. And then we're going to use the data set to find out what these coefficients are, the B, the beta. Okay? And that's how we build the model. So we need to build the model from data. So in machine learning, this is a supervised approach. So we already have the data, and what we're trying to find is how much each of these variables seems to be associated with interest rate. So the beta will give us the kind of weight, or as we call the coefficient, of how each particular variable is associated with interest rate. And there's an equation here, but let me just point out that actually this is fairly simple. All that is happening here is that we are identifying the y value, so the interest rate that's actually in the data, and we're identifying the predicted y value based on the line that we came up with the regression. The regression is a line. So this line that we can find based on number of points is going to give us some predicted values, right? So for example, if you figure out this line over here is the line of the regression equation. Well, we're going to have an y point that is over here, and this y point may have the value of 100. However, if you put, and then let's say then there's another value here, that's 80. Okay, all of these points, note that there's a distance between the points and the line. So the line doesn't predict the point specifically. And the difference between these points, the actual value, and the line itself, because the line will give you a value over here. But the point is actually over here, right? So all of this difference between the point and the line, these are the residuals, and that's what this is referring to. And then the sum of squared errors is the sum of all of these differences between the line and the points, and that's the error rate, and that's the E that we see here. And also there's another image over here. So this is the residuals, and what the regression process algorithm does is find this line that minimizes all the points to the line. Okay, let's talk a little bit about the predictors. I'm going to stop here. We'll continue in the next one.